What if I told you that right now, something is watching us from the edge of our solar system, and it knows exactly where it's going?
A supposed comet is catching the attention of some of the nation's most renowned scientists, as one Harvard professor is raising the theory this may actually be a piece of alien technology.
This isn't science fiction. This is 3I Atlas, and based on the mounting evidence, I'd rank the probability of this being something extraordinary at about 1 in 500. Those aren't lottery odds. Those are pay attention odds. Here's what we know. We don't have the technology to intercept or deal with anything truly alien if it showed up tomorrow.
Do we have the technology and the ability to intercept?
Officially, no.
It challenges everything we thought we understood about our cosmic neighborhood. And here's the kicker. Whatever this thing is, we may never see it again. July 1st started like any other night at the survey facility in Chile. Automated systems scanning the heavens, cataloging the usual suspects, asteroids, comets, space debris. Then something appeared on the monitors that made astronomers do a double take. A dim speck, racing across the star field from the direction of Sagittarius, cutting through the dense, star-packed core of our galaxy. Initially, it looked ordinary enough, another distant comet, perhaps a wanderer from the far reaches of our solar system. But that assumption crumbled the moment they calculated its speed. This object was moving too fast. Way too fast to be gravitationally bound to our sun. Its trajectory curved in a perfect hyperbolic arc, the signature of something that came from deep space and was destined to leave the same way, never to return. But speed wasn't what sent shivers down astronomers' spines. It was the precision. Remember that question I asked? About something watching us? Keep that in mind. Most interstellar visitors, objects like Oumuamua or 2I/Borisov, arrive like cosmic pinballs, tumbling in at chaotic angles, crossing through our planetary system wherever gravity happens to fling them. They're random, uncontrolled, natural. 3I Atlas is different. This silent intruder approached along a trajectory just 5 degrees off the ecliptic plane, that invisible highway where all our major planets orbit. Think about that for a moment. Of all the possible angles it could have chosen from the vastness of interstellar space, it picked the one that aligns almost perfectly with our solar system's main traffic lane. But it gets stranger. As orbital calculations became more refined, a chilling pattern emerged. This wasn't just crossing our system at a convenient angle, it was scheduled for a grand tour. Venus first, then Mars, then Jupiter, in that exact sequence. A gravity-assist choreography that's identical to the trajectories we engineer for our most sophisticated space missions. Avi Loeb, Harvard's maverick astrophysicist who's never been afraid to ask uncomfortable questions, the probability of such a precise sequence occurring by pure gravitational chance? Roughly 1 in 20,000. That's not proof of anything. But it's the kind of number that refuses to be ignored. And then came the size estimates. Based on brightness calculations and assuming a typical dark, rocky surface, 3I Atlas could measure up to 20 kilometers across. That would make it the largest interstellar object humanity has ever observed, a silent giant drifting through our cosmic backyard. Yet despite its massive scale, something was missing during its initial approach. No jets of gas. No outgassing. No tail. No signs of the typical comet behavior we've come to expect. Just silence. That question about something watching us? Starting to feel less hypothetical, isn't it? When you reconstruct 3I Atlas's path through space, you don't see chaos. You see calculation. Its retrograde orbit, moving against the natural flow of planetary motion, was expected for an interstellar visitor. But its low inclination, skimming just above the ecliptic plane, sets it apart from every other known cosmic wanderer. Most objects from distant star systems dive into our solar system at steep angles, plunging down from above or below the solar plane like falling stones. But 3I Atlas glides through the same spatial corridors we use to launch our most efficient interplanetary probes, the regions that minimize energy expenditure while maximizing gravitational assists. If you asked a team of NASA engineers to design the perfect reconnaissance flyby of the inner solar system, something that could survey our planets without stopping. They might propose exactly this trajectory. That doesn't prove artificial origin, but it forces an unsettling question. Why does a supposedly natural object move with such elegant intentionality? Some scientists dismiss this as statistical coincidence, an unlikely but possible result of gravitational lottery. Others aren't convinced. Loeb continues advocating for what he calls rigorous open-mindedness, urging the scientific community to treat 3I Atlas as a pedagogical case study. Not because we have smoking gun evidence of alien technology, but because the constellation of anomalies demands deeper investigation. In his words, "We lose nothing by asking harder questions. We may gain everything if we discover something we weren't supposed to see." Here's where the story takes a truly unnerving turn. As 3I Atlas races toward its closest approach to our Sun, it will slip behind the solar disk from Earth's perspective, entering an observational dead zone precisely when comet activity typically peaks. Ground-based telescopes will lose line of sight. Hubble will be effectively blinded by solar glare. Even the James Webb Space Telescope must carefully navigate pointing restrictions to avoid catastrophic damage from our star's radiation. To most astronomers, this is simply cosmic bad luck. But to others, the timing feels almost tactical. As if the object were designed to vanish at the exact moment when our scrutiny would be most intense. Remember that watching presence I mentioned? What if it doesn't want to be fully observed? While this might sound like science fiction paranoia, the physics is straightforward. A trajectory adjustment of just a few centimeters per second, maintained over the years of interstellar travel, would be sufficient to achieve such precise timing. If 3I Atlas possesses any form of propulsion system, even ancient or passive technology, this level of control would be entirely plausible. Of course, there's no direct evidence of such mechanisms. Not yet. But we know what signatures to hunt for, which is why our most advanced instruments have been dissecting every photon of light this object emits, searching for chemical fingerprints that might reveal its true nature. For weeks, telescopes across Earth and in orbit have maintained constant surveillance, trying to decode the fundamental question: what exactly are we looking at? Initially, 3I Atlas remained cryptically dormant, a cold, massive nucleus gliding through space without obvious activity. But as solar radiation began working its influence, something awakened. A faint coma of gas and dust slowly materialized around the core. Even this awakening defied expectations. Most comets develop tails that stream away from the sun like cosmic windsocks, pushed by solar radiation pressure. But portions of 3I Atlas's dust plume appeared to curve toward our star, suggesting unusually dense or metallic particles that resist typical solar forces. The spectroscopic analysis from James Webb and ground-based observatories like Gemini South revealed an even deeper puzzle. The chemical signature showed familiar ingredients: water ice, carbon-rich dust, silicates, organic molecules. Standard comet composition, at first glance. But these materials weren't fresh. They were ancient, possibly older than our solar system itself, preserved in pristine condition as if sealed in a cosmic time capsule for 7 billion years. Minimal radiation damage, minimal thermal cycling, spectral features suggesting they had never experienced close stellar proximity until now. Even more perplexing was the brightness mismatch. The coma glowed more intensely than expected for the estimated core size, prompting some researchers to theorize that the surface might be unusually efficient at light scattering, perhaps due to a smooth texture, or even an engineered shell. What if that watching presence has been traveling longer than our planet has existed? Perhaps the most haunting aspect of 3I Atlas is where it came from. Orbital reconstruction traces its journey back through the thick disk of the Milky Way, a region dense with ancient stars and primordial debris, far removed from the active stellar nurseries where planets typically form. This suggests an object that's been wandering the galaxy for eons, potentially since the cosmos was young. It could be a fossil, a fragment of galactic memory, unchanged since the universe's dawn. Or it could be something entirely different, a designed artifact, a dormant probe, a sentinel awakened by starlight after billions of years of patient drift. Each new data point deepened rather than resolved the mystery. Every signature, chemical, optical, dynamic, added another layer to a profile that simply doesn't match our models of natural comet behavior. No responsible scientist claims certainty. No one is declaring alien probe without irrefutable evidence. But the conversation has evolved from outright dismissal to genuine consideration, because 3I Atlas is pushing us beyond the comfortable boundaries of our scientific models. In those boundaries, we're finding shadows of possibilities we don't yet understand. Soon, 3I Atlas will complete its vanishing act, slipping behind solar glare where even our most powerful instruments cannot follow. When it emerges weeks later, dimmer, colder, already departing, it will begin its silent journey back into the interstellar void from which it came. We'll be left with our data. Spectra, images, measurements. All remarkable, none conclusive. Because even with humanity's most sophisticated technology, we may never definitively determine whether this was an extraordinary comet or something far more deliberate. Something designed to approach closely but not too closely, to reveal just enough while concealing everything essential. Maybe it's coincidence, a natural relic following an improbable path through our cosmic neighborhood. But what if that watching presence was never trying to communicate with us? What if it was simply taking notes? But if it's not coincidence, if the trajectory, the chemistry, the timing all point toward artificial origins, then 3I Atlas might represent the first message we've ever received from a civilization lost to deep time, or one that continues observing from the galactic shadows. A probe that doesn't communicate, doesn't land, doesn't linger. It simply studies and moves on, disappearing like a ghost. Perhaps that's the most unsettling realization of all. Not that we might have been visited, but that we weren't the destination. Just a waypoint in an ancient survey mission. A brief stop on a journey through the dark that began before Earth existed and will continue long after our sun dies. Whatever the truth, this moment matters profoundly. 3I Atlas has accomplished what few celestial objects ever manage. It's forced us to question our fundamental assumptions, expand our definitions of possibility, and confront once more the ultimate question that has haunted humanity since we first looked up at the stars. What if something has been watching us all along, and we're only now beginning to notice? Are we truly alone in the universe, or have we simply not been paying close enough attention to the signals all around us? The cosmos isn't empty. It never was. And now, finally, we might be learning how to see what's actually out there. If you've followed this journey to the end, you're among the few who are truly listening. The mystery continues, the silence persists, and the thrill of not knowing grows stronger with each passing day. Because somewhere out there, 3I Atlas is carrying its secrets back into the darkness between stars. And we may never get another chance to ask what it learned about us during its brief, calculated visit to our small corner of the galaxy. The sky has stories to tell. We're just beginning to learn how to hear them.